There I am. It's like, hi, it's my hand. Hey, everybody. Welcome back to 3D Hangouts. My name is Noé Ruiz. I'm a designer here at Adafruit. Joining me every week is my brother Pedro Ruiz.
Good
Hello.
morning, everybody. Pedro is Creative Tech here at Adafruit, and every week we're here to share 3D printed projects featuring electronics from Adafruit.
Yeah, that's right. This is a show we combine 3D printing and DIY electronics to make inspirational projects. Hello, everybody. It is Wednesday, February 14th, 2024. We're doing episode 431.
Valentine's.
Happy Valentine's Day, everybody. We're hanging out in the Discord server. If you'd like to join us, you go to discord.gg/Adafruit. We're hanging out in the live broadcast chat channel. We're going to shout out folks that are watching live. We're streaming on Facebook, YouTube, Twitch, and X, formerly known as Twitter. Pedro. I'm getting lost in the tabs, but here we go. Shout outs to Jim Hendrickson, Squid.jpg, Gary Z hanging out in the Adafruit Discord server. And on YouTube, we're hanging out there as well. And the other places I said.
Let's see on YouTube. YouTube chat. Good morning. We got Kinger North. We got Bob Pier Fleece and Cavillon Dome. Shout outs to the awesome looking designs, he says. Cool.
Yay.
I got a question from Bob real quick. We were looking at this. I think you're going to have to contact forums for that one. If that's not loading.
Support, you can email support at adafruit.com. Our support engineers can assist you in all of the questions you might have with hardware.
Yes.
Yeah, they're pretty quick too and responsive. So definitely check out support at adafruit.com for all your technical questions. It's like 24/7.
This sounds like you might need the board swapped though, but that's pretty fast.
Cool. All right. I'm going to take a look at adafruit.com/free and see what kind of deals are going on this week. Free stuff. If your order is $99 or more, you're getting a free PCB coaster with a golden Adafruit logo. If your order is $149 or more, you'll get the free PCB coaster plus an Adafruit KB2040. That's that lovely dev board with the RP2040 chip, STEMMA QT port, tons of GPIO, and a Pro Micro format. If your order is $199 or more, you get the KB2040, the PCB coaster, and free UPS ground shipping for continental US only. And if your order is $299 or more, you get the free shipping, the KB2040, the PCB coaster, and a free Circuit Playground Express. Adafruit.com/free for all the details. These get automatically added to your cart. No need for coupons with that. But on top of that, we have a coupon code for today. 10% off your total order. Clock time. We do appreciate your orders as it supports everybody here at Adafruit. And that is the freebies.
Posting all in the chats.
Pedro's posting links. I'm hanging out. I know what time it is.
It's
11:04 p.m. Eastern Time.
What time is it?
11
clock time.
Clock time. Where's the code? Clock time. All right. So this week. Oh man, I gotta manage Windows here. There we go. Let me flip that around. All right. This week is a 3D printed mid-century modern designed clock with a 1.2-inch 7-segment LED display powered by a Feather RP2040 running CircuitPython code. This is a collab project with Liz Clark. You can change the time using the Rotary encoder on the side here. Press and hold, and you go into edit mode. A little dot here lets you know that you are editing the hour. If you click again, it'll switch the dot to the lower half of the screen. And that means you're editing the minutes, and you use the Rotary encoder to change the hour or the minutes, so you can rotate it back and forth. And then you notice there's another dot up here. What's that other dot mean? Well, it means it is PM or AM. If there's a dot, it means it's PM. And if there's no dot, it is AM. It is a 12-hour clock. But you can change it to a 24-hour clock if you like in the CircuitPython code. So let me fix the time because I changed it. Go back to hours. It is 11:05. And you know what I forgot to mention is it has a real time clock module. It's the DS3231, which you may have remembered from yesterday's product pick of the week from JP. It was half off. All of the components are connected together with STEMMA QT cables, making it a kind of a no solder project, which is pretty cool. The rotary encoders now come pre-soldered, which is really nice. And I think the only thing you will have to solder is the LED display. So this is the 1.2-inch LED display, and we currently have two versions, one that's red and another one's yellow. Pedro, you have the yellow version, which you can show. Do a little swap here. And they look drastically
different shade of red.
Yeah, it looks a little bit different there, but it is yellow. You can see in the Learn Guide photos. It comes out very nice and yellow. Mine actually looks more yellow than yours. How funny. But in any way, you can print the 3D printed parts in any color. Yours looks a lot more kind of, I don't know, future kind of colors. It's got that kind of glitter black, dark purple, a little bit more masculine. I've got these fun mint green and orange. And then we have these legs here that get attached to the bottom that kind of give it this cool angle. And I have them printed in this kind of coffee brown, and you have them in that purple. Very cool. One of the things we used to make the display look really nice is these gel filters to kind of soften, not really soften. What would you say it does? It kind of polarizes the LEDs so they look a little bit more legible. Not a little bit, a lot more legible. So you can see Pedro just popped his faceplate off. And you can see it's a huge difference. I think most clocks that have these 7-segment displays probably have some sort of filter.
There's no way you can read that.
Yeah, that looks awful. You can't read it. Even in even not looking it through a webcam, it really is hard to see without the gel filter. You can pick those up from Amazon or other stores. You can get them in different colors, and you can cut them to size with scissors or a hobby knife. But yeah, that was really important to get that in there, because otherwise the photos would be very hard to get. So that's kind of the project in a nutshell. Really good example of how you can use the RTC module to display time on these 7-segment displays. We really didn't want it to be an internet clock, mainly because sometimes the internet goes down, and it's kind of nice to have a clock that isn't dependent on the internet. And we don't really have... We didn't have a project that was in CircuitPython on the Adafruit Learn system that used that real-time clock module in CircuitPython. I think we have one in Arduino from JP a couple of years back, but this one all in CircuitPython, and it's all using the latest STEMMA QT enabled electronics. I have it powered through USB-C, so you can optionally use a battery if you like with an on-off switch, since the Feather has built-in battery charging, or you could use a USB battery bank like Pedro has there. I have mine plugged into a wall adapter, but that's pretty much the gist of it. It's just a nice-looking, simple, minimalistic clock. All done in CircuitPython.
Yeah, real quick. Question or just comment from Calvin Doom saying that blue color looks like a Weller soldering iron.
Yeah. This is I think it's called Mint Green from Hatchbox. So they make some pretty good filaments. I'm using the Hatchbox filament. I think Pedro using the Everyone filament for the,
it's got that
the darker tones. Yeah.
See the glitters
Too
there.
Cool. Yeah. Everything snap fits. There's no supports.
And then a follow-up question here. Does the clock design allow for a speaker?
there's plenty of room in the clock for adding a speaker, maybe even like a 1x4 Neo key or a panel mount button. There's definitely room in there for a speaker for sure. Yeah, it's a good starting point. Like if you want to add features to it, there's plenty of room in there for some more components.
Yeah, definitely
Yeah.
inside here. You have your
Yeah.
mounting holes up there. Or even down here, there's plenty of room still available.
Yeah, and again, there's room for a battery as well. So if you want to put like one of those 1200, I think 1200 or 2200 milliamp LiPo batteries, the cylindrical ones, those work pretty well.
Yep, so definitely upgradable. Like we say in the video, it's perfect for upgrading and adding, plussing it up however you would like.
Yeah, if you do want to add sound, I would recommend the Feather Prop Maker RP2040 because it has a built-in I2S amplifier. So you get some nice audio out, and it has screw block terminals, so it'd be easy to like just connect those up. Yeah. Yep. Or if you want a talking clock, we also have a Liz's AdaBot talking clock, which she did last year, I think in December, which will tell you what the time is with AdaBot's voice. Maybe you can mash them together. That'd be kind of cool, huh? All right, let's take a look at the Learn Guide. We'll kind of browse through a little bit. So it looks like we have everything in stock except the display. If you ever want to get notified when these things are back in stock, there's always a little sign up on the side here. Out of stock, you can enter your email and get notified when these are back in stock. This particular product comes with the LED display.
Is the yellow one in stock?
Let's take a look. If you scroll down, you'll see like recommended products, and here's the yellow one. This one is also out of stock. There is a buy on DigiKey button. Let's see if it's available on DigiKey. Our partners at DigiKey. Let me click on it. They have 6 in stock. Get it from DigiKey. They have fast shipping, and they're our partners. So you can purchase from DigiKey if you like. Yeah, it says it can ship immediately. That means they have it on hand. Pretty cool. How about that? So these are in stock at DigiKey. Pick those up. We like DigiKey. The Feather is in stock. The RTC is still in stock. If you got one yesterday, you got it half off. So congrats on that. You will need a CR1220 coin cell battery because that's how it is able to keep track of time when the device is shut off. So that's how the RTC works. Other than that, you got cables and the rotary encoder. The rotary encoder comes, soldered already with the rotary encoder itself. Those are out of stock, unfortunately, but you can get the PCB breakout with no encoder and buy them separately. So you have options there. But yeah, recently these were added to the store with them pre-soldered on. Very nice. I think that's about it.
Speeds up. Yeah, definitely speeds up workflow. It is a little tricky to solder those guys on. Having it hang upside down or not.
Right. Yeah.
We had to set up the little clamps for it. This is a lot easier.
Handful of screws. I have them all listed here. So if you want to pick those up, you can get them from. You can get assortment packs from all sorts of different places. And then I linked these light diffuser gel overlays from Amazon, but you could search for them elsewhere. They come in different colors. The one I'm using is this kind of smoky black.
Yeah.
That's the one I use. But I suppose you could use any of these other ones, and they would be okay too. But they're meant for like, yeah. They're meant for film.
Sorry. I was just gonna say, that's exactly why we picked these up. So we were lucky that we had these lying around.
Yeah, I picked out a pack a couple of years back. It's called T-Black. Look at that. Yeah, and these come in like a 11 by 8 inches, so not too big. You should be able to cut them. Okay, so I think that's all the products. The circuit diagram. We put this together using the Fritzing software. If you want to create your own, you can download Fritzing. And then we have a link to the Adafruit library for fritzing parts on GitHub, so you can get those up. That's how we put them together. Pretty straightforward. STEMMA connectors to connect everything together. Pretty nice. For the CAD files, everything's the STLs are oriented to print as is, but you could always reorient them. If you're printing them in something like resin or something, you might want to do that. Add some supports for resin. But if you're doing the FDM style 3D printers, they're ready to go. Just choose your colors. We also have a step file of the whole design assembly. So if you want to remix it, you can import it into FreeCAD or Blender and add all sorts of different modifications to it. Fusion 360 has all the sketches and parametric timelines, so you can update those a little bit easier. You can download these separate parts, like the feather or the display or the rotary encoder or the DS3231 real-time clock module from our GitHub parts repo. I got a link for that there. Those are handy for importing into your CAD package. So yeah, the biggest part is going to be the case, and that comes out to 140 millimeters by 66 millimeters by 80 millimeters. So just be aware, you kind of need a minimum build volume of that to be able to print it out. Otherwise, you can send it off to like PCBWay if you want to get them printed in like resin or resin. I said resin. They have nylon printing as well, and maybe even CNC if you want to pay the price. Get it in some aluminum. That'd be kind of cool. But that's it for the CAD stuff. Next page walks through installing CircuitPython. If you haven't done it yet, there's how to do it. There's a whole page on how to update your board to the latest version of CircuitPython. Shout out to Liz for putting together the coding page. You can use the download project bundle to get all the libraries and dependencies for this project. It's using the DS3231 library, the library for the LED display driver, which is the HT16K33. The bounce library is used, I think, for like doing a long press, for going into edit mode, and then the seesaw library for the rotary encoder and I2C stuff. So the main thing you want to look at is changing the minimum and maximum brightness. So one of the cool features about this is that the display can have different brightnesses depending on the time of day. So if you want it to be not so bright during night, so you're not blinded at night, you can turn that down all the way down to like 0.01 or 1 for max brightness during the day. So that's how it's set up here. You just want to change that how you like. It is set up on 24-hour time, so just be aware of that. When you initially set up your real-time clock module, you want to update the line here, which says time.struct. So you'll want to change the year, the month, the date, and just make that to your current time. Turn it on to true on the first time, and then turn it to false when you have the time set. And it's pretty straightforward. Lots of comments here. So you can change it up if you like. And then Liz has a nice code breakdown of all the different spots. For example, if you wanted to change it from being a 12-hour to 24-hour, you could update that part here where it's doing the whole clock conversion. Okay, very good. Next page is the wiring, which is pretty much plug everything together. We do have a product guide on soldering the LED display to the LED backpack breakout. Comes with some pins. There's only one way to put it in correctly, so just install it and solder those pins, and you'll want to trim those leads short so they're not poking through any of the other components. So I start off with...
Wow. I did not. It's so close to the STEMMA.
Oh, you didn't trim your pins?
Yeah, I did not.
I get,
so you'll be super close to the encoder. It's not touching, but it's pretty close.
Okay, well, if you're in a rush, don't trip the...
I didn't realize.
I thought they would... Yeah, anyway. I guess it's optional. You can trim it or not. Let's see. The coin cell battery gets installed to the RTC module. There's a nice symbol, for positive. It's facing up. I think you can connect it differently, but for the STEMMA QT cables, like I went with this orientation. So if you want to follow that, you got the photo there to reference. The LED breakout has a dedicated mount. It only fits one way, so I'm using M2 size screws and hex nuts to attach that together, but it gets attached to the back of the display instead of the front. That's just kind of the way it worked out. And then there's a dedicated PCB mount for the Feather and the RTC module. Those get attached directly to the built-in standoffs of the PCB mount with these M2 screws. You just kind of create the threads with the screws themselves. So pretty clean that way. And then we have everything connected. You want to cut your filter down to size. I have a recommended size here. It's about 5.2 inches by 2 inches, give or take.
Oh, I think it's easier to trace.
You trace it?
Part.
Yeah, you trace the front cover plate. That's a good way to do it too. That's pretty much what I did. I just took the dimensions from CAD and threw it in there. Mm-hmm. But yeah, you could use that as a straight edge, I guess. The first thing you want to do is put once all the mounts are secured, you can fit the LED display through the casing. And then that way you can line it up with the built-in standoffs, and those get attached with those M3 screws. Make sure the orientation is correct. You can use the silk screen, the lettering on the silk screen, the labels, as a point of reference to know which way is up, the right way up. And then the next part is to panel mount the rotary encoder. Pretty straightforward. The rotary encoders come with a hex nut and a washer. You want to install those properly. And then the rotary knob just gets press fitted onto the shaft of the rotary encoder. And then depending on if you want the base legs or not, you'll want to kind of position the PCB mount with the mounting holes lined up to the 4 mounting holes that are on the bottom of the casing. Hold those in place, and then you want to kind of sandwich in between the casing, the base legs, and the PCB mount, because we're actually using the same screws to secure the base legs to the casing to the PCB mount. So it kind of gets sandwiched together with these M3 screws. So you kind of need the longer screws. These are 10 millimeter long screws, but it's kind of neat that you can you reuse those same 4 screws for the base legs. I found that to just be kind of a easy way to kind of attach those base legs instead of doing them individually. So that's what I got going on there. And then you use some hex nuts to just kind of keep it in. Although to be honest, I didn't use hex nuts. Did you use hex nuts, Pedro?
No, I didn't. I was able to, like you said, create the threads right into there.
Yeah. So whether or not you want it, hex nuts or not, it's optional. And then the back cover is kind of one of the last parts. It only goes one way because there's these nice fillets that kind of key and register the parts together. There's only one hole, and that's for the USB-C port. And then once the back cover is on, you can just lay that pre-cut gel filter over the LED display, and then the faceplate just press fits, and it should have a nice tight fit. And that's it. That's the whole build. Man, what a difference. Cool. Here's a photo of the gel filter off and on. It's like night and day.
Oh, yeah. And like some people were saying that it looks like it turned it pink.
It does look pink. It's mainly because the flash or the lighting or whatever. It just makes it look
color
pink.
Correction too.
Yeah, the color correction too.
Like I don't have a reference of what that pink really looks like, so I just took a guess on what and matched all the pinks together.
Yeah, I suppose you could use one of the colored gel filters to kind of make it more pink. Maybe like a yellow tint or something would make the red look more. Because if you color mix red with yellow, I think you get pink. Anyway, there's a usage page that lets you know how to change the time. We tend to do usage pages just like as a reference. Like, how do I use the thing once it's all built? So
Yeah.
I already did a demo, but you press and hold down the rotary encoder for, I think, a second, and then the LED display, the characters will start blinking. That lets you know you're in edit mode. You're editing the hour first, and you press once to switch it to the minutes, and then you can use the rotary encoder again to change the minutes, and then press and hold to save and exit. I haven't used a clock, a digital clock in a while, but I think that's how they work, right?
Mm-hmm. Yeah.
I don't think I remember having one like as a kid, but I think it had buttons. I don't think it had a. And there would always be like a set
At the top.
time button that you would hold down, and sometimes
Yeah,
it
it
was
was more
easy, sometimes
complicated.
it was confusing. I don't know.
Uh-huh.
I feel like this is more intuitive with the rotary encoder.
Oh, definitely. All right, quick comment from Connor asking, would it be difficult to add a proximity sensor of some time to the clock? I'm guessing probably in like some around this area. So when you walk close, it'll turn on the display and then turn it off.
Oh, that's
After a
interesting.
couple, like a minute or so after not seeing someone.
Yeah.
I think it's a cool addition to add.
Yeah, that sounds fun. I would, yeah, maybe up on the top, there's more space there for it, for a proximity sensor.
Mhm.
Yeah.
In this area.
Cavill Doom is saying yellow will remove blue, which is less pink. That's my
Oops.
color theory. Yeah, my bad. So I guess use a blue filter to make it more pink. Anyway, the pack has all sorts of colors, so mix and match them if you want.
Yeah, you can try them out, mix them together. Jim Hendrickson has a really good point that the digital clocks, the biggest pain about them was that you couldn't only set them forward. You can go back and forth between setting the clock. And that's true. Remember that you'd hold it down to have it go fast, and then it'd like go past it because it's going too fast. You're like, oh no, I got to do it again.
Yeah. Huh.
I think the easiest is on our oven, where it's literally you push the clock and then just push up or down. There's no holding down anything.
Yeah. Yeah. I remember it being a challenge to change the time in our cars in the 90s.
Oh, yeah.
You'd be like, how do I do it again? Do I hold it down? Yeah.
Mm-hmm.
Changing clocks is one of my pet peeves, says Andy Calloway. Well, not with this one. Rotary encoders, especially ones with a button, are very, very versatile for lots of things, really. Yeah, I agree. One of my favorite tactile controls is.
In the Discord chat there, if you scroll up a little bit, DJ Devin has these rubber feet that he used. I'm going to point those out if you want to
Oh, yeah, these are cool.
That style. Mm-hmm.
Yeah, you could always add your own rubber feet as well.
Yep.
You can add some holes. You know, I originally did have just rubber feet with the self-adhesives on it originally.
Mm-hmm.
But
yeah,
sometime
I like
over
angle, though.
what do I add this like kind of fun legs? Because I was looking at some mid-century modern furniture, and I was like, they got these cool angles. Maybe I can add that.
Those,
yeah. So
yeah, you could even add those on the bottom of these feet, huh? Make it all nice and grippy. Although
they might be a little bit too slim.
Nice. Like it doesn't slide as much.
Yeah, right. Yeah, I thought that was interesting.
Like the center of gravity is pretty low.
What is Duester saying? Does it bother anybody that the primo tech of the day just a few short years ago is now so confusing to us? Yeah.
All right.
Cool. Well, that's this week's project. If you want to pick up any of the stuff, remember, DigiKey has some stuff in stock. You can use our coupon code to get 10% off using the coupon code CLOCKTIME. And now it is time for what are you prototyping this week? Pedro has a Star Wars looking Rebels.
Yeah, so this is going to be the shoulder bot, which is pretty much a servo controlled camera. So here's what we got so far for that prototype. I have it on a tripod, so Brent could do some coding on it. It'll be a lot more easier than having to try to balance it on your shoulder. So it's a tripod version for now. We're going to update the design so it's Minerva the owl. So it'll have like the robot one-eyed bird that'll look around like that. So what we have here is, I want to call this like a pref board version of it, since you have all these abilities to like attach STEMMA boards for additional sensing. You have all of your port openings on all the sides right here. It's actually how the NeoPixel ring is attached to the A0 port on the Memento. And then the servo, I'm assuming, is going to plug into the A1 port. And then you got your STEMMA. So if you want to, again, I think there's room for like 2 or 3 of the 0.9-inch STEMMA boards that can attach to there. Everything is snap fit, so it can all be disassembled pretty easily. So if you don't need the tripod portion here, you can have that. See how the servo is attached to that. A little bit of intricacy in the terms of the way the horn is sandwiched in to the 1/4 inch or 3/8 by 1/4 inch tripod adapter. So that is sandwiching in the servo horns that these guys come with. So that's attached on there, very nice. And there's the screw also that is holding the horn in place. And yeah, so that'll go around, pan around, and Brent has the face detection code working. So when it'll detect a face, it'll light up the LEDs from red, yellow to green when it spots a face, and then take a picture.
Yeah.
Have the buttons on the back. So if you want to do any additional UI selection,
you can see the display.
So you have the ability to get all that. And let me go ahead and actually turn it on. It has the Arduino code on there, but I'm just using it to show that you do actually have quite a bit of what's it called, the view angle on here.
Yes.
So you're not actually blocking that. That was one of my fears too. Yeah. Since it's pointing so far out that you would block stuff, but
yeah, it looks like it's not obstructing the view at all, so it looks good. Cool.
So yeah, the default Arduino one. Oh, there it is. Yeah. The default Arduino does not have the controls for the LEDs. I'll go ahead and put on the bin file that Brent has available.
So Brent recently
didn't finish the case until last night.
Brent recently published his guide on kind of getting the facial detection and recognition on the Memento working. So folks want to play around with it now. I think the only addition is that the servo isn't, a part of this project, but that's for Pedro's project. You get a bin file, and then you use the ESP web tool to upload the bin file. And then he has a usage page and how it works. You can see here that it kind of draws a box, and it detects your nose, eyes, and your mouth. And then you get some overlay text that says whether it detects the face or not. So that's kind of cool. Got these nice GIFs here to let you know kind of what the UI looks like. Here's the light working. So it does use the NeoPixel ring. Or if you have access to the front-facing camera plate that has the built-in LED ring, you can either use that or this. But yeah, it's cool. I'm definitely going to try it out later this week. And then I'm just now kind of walking through the.
I know.
I've been in the weeds with this project.
Exactly. Yeah.
But I guess there's some configurable stuff, code history and explanation. This project uses an example written by me, no dev, for Espresso Systems. So there's a GitHub repo, and then he kind of walks through all the different bits here for doing the face detection. Pretty cool. So this will be our first kind of robot that can actually detect faces.
Yeah.
That's pretty cool. I think later down we'll add crazy features like sound effects and, actually track maybe. Yeah. But right now it's just like really want to get a base, feature set where it's like, okay, we can detect a face. Let's light up a NeoPixel ring to say it's green if it detects a face or red if it's not detected. Just really, basic
Yeah, that's why I'm releasing this design as well. Or since he did say he's going to split it up in 2 different guides, so maybe we should do the same thing, because this works very well as just a desktop dev board, and then the case for it too. Like, just because it has the ability to have all those expansion
the mounting points,
accessories. Yeah. So this is like, oh wow, this is why I didn't start on the owl. I was like, let me finish this, because this
it's a
should
good prototypey kind of design. It's modular as
exactly.
well. You can add different parts to the top or the bottom of the case.
The modular.
It's a
Exactly.
lot like the doorbell project, where it's like the sleeve design that prints upright. You figured out the snaps, and I like that
Exactly.
this version actually gives you access to the display and the onboard buttons, because the doorbell, it didn't really. You don't need
I
the
mean,
display.
it's a completely different functionality for it. It's supposed to hang outside. This, it's supposed to be like on your desk, or where you can have access to it to be able to interact with it as well, and then upgrade it or test code for what we're going to use it later down the line, the shoulder bot. So you can make sure all that works before I update the case for it. I think
everything's
really
accessible to the SD card, all the ports.
And then we do have the 420 milliamp hour battery inside here, but because we have all this space, you can
add a bigger one,
maybe much bigger one. Yeah. And I like how
1200.
Yeah, all the additional space in here, nothing's wasted. So we're using it to coil up all the wires. So, I mean, you are going to have to cut this to add the 3-port JST to connect it, but you're saving in, having to shorten wires. Where you can just coil it up and have it hidden inside there, or have your battery be inside there. So you're.
Did you need a question? Did you need any supports for the casing?
Any what?
Any support material for the casing, or does it just print without any supports?
Something needed supports. Oh, yeah. The only thing that needed supports is the base plate for
really? I want to thumb.
Yeah, I should have grabbed it. But everything else, prints without supports. It prints straight up. You can see here some of the design considerations, just making sure that the snaps, where to put the snap on each part of the object, so that you don't have to print with supports. And then you have a bunch of little areas to have like the cables coming out of. So on both sides, so you can pass through your STEMMA. Or the STEMMA can actually go through the grills here as well.
Yeah, that's
for
good.
whatever positioning you might want. So nice little way to pretty much for testing and for
lots of ventilation. With all the grids.
One over.
I'm surprised the vents printed nice like that, because they're
me too.
I don't know, they're about like 12 or 15 millimeters across, so that's some pretty good active cooling on that printer.
All the printers had turns printing all these parts as I'm trying to figure everything. So the Smart Pro, or the SP Creality SP2, they all printed parts and everything fits together.
Cool.
The base plate is the only part that needs support material, and only for like 1 millimeter. And I'll show it off next week why you need the supports, because of the way the overhangs are, for the way that it sandwiches the servo horn.
Yep. All right, we got some comments. DJ Devin saying, really cool, great design. Thank you. Is there a guide on doing this with CircuitPython and Adafruit.io, or currently only for Whippersnapper?
I think this is for
If you're talking about the face detection, it's like an Arduino project, because like the support is only through the Espressive stuff. Squid.jpg, really love the mounting slots. I don't know the name of the aesthetic, but it's very raw with the exposed. I was thinking kind of like a Rebels Star Wars, because like in that universe, like everything's like kind of kit bashed together. It's like a little engine here and a little bit of that. So that's kind of cool.
Having the screws exposed, I think, helps out with that too, or in the grills as well. Very kind of grungy. I should probably make this grill. I don't know. I was going to say make it compatible with the STEMMA spacing as well, so you could mount something here. But
it's more for. I think it's more for aesthetics.
Oh, this one's supposed to be for aesthetics. This fake like grill, whatever those bumps are. I think it's supposed to be like a radiator for heat, so it disperses the heat out from these.
Yeah.
If it was metal.
DJ Devin is asking if the 2500 milliamp battery is the biggest single cell dichromatic LiPo battery that Adafruit carries. Looks like it would fit in the top compartment.
Yeah,
I don't know. Do you think it would fit?
I mean, you can just elongate this.
Okay.
Should fit.
Yeah, I think it's too wide.
Might be.
I'm trying to search for it. There it is. Yeah, it's a little bit too wide. I think the 1200 might work better, but don't know yet. But yeah, I think that's the biggest single cell that we carry. The next one up is the 6600, right?
Yeah, but that's
not the, the soft, the harder LiPo. We have a
bottom.
There we go. We have the category for all the LiPos. Pretty sure the 2500 is the biggest one. Oh yeah, we have 2000. That's cool. Forgot about that one. It's less. It's a little bit more slim.
The 1200 is about the same size and about half the.
Yeah, I like these because they're nice and rigid. They're not soft. They're kind of a little bit more hard shell. Anywho, good stuff. All right, and that's what you're prototyping.
Yes, this will be out.
Shoulder bot.
2 weeks, something like that. The shoulder bot in about 3 or a month. So it took me a while to get everything mounted on there. Let's see how this guy's all wired in. So it's ready to go. I'm just gonna get that bin file on there. It just snaps right in.
Yeah. Yeah. So next week you'll have some code to play with.
Yeah.
It's just like the
I'm gonna do
baseline facial recognition stuff. Cool.
Yep. So I don't think we'll have it won't be completed for next week, but we'll release it the week after.
Yeah. Have my clock in view. Okay. Let's move on to the next segment with Time-lapse Tuesday. Every Tuesday, Pedro finds a fun, timely.
I think Declan came in and took it.
That's funny. Declan Pedro's a 3-year-old. So I have a time-lapse video. Let's play it now to celebrate. What do we celebrate now? The recent news with stingrays and sharks. This is a Blobtopus. So it's the blobfish and an octopus offspring.
And it's supposed to be for Valentine's Day.
For Valentine's Day. Yeah. So it's a printed place design, flexible appendages. I suppose there are 8 of them. Am I right? Or is there 8?
2, 4, 6. Wait a minute. 2, 4, 6, 7.
So it's a septopus. It doesn't even have 8 tentacles. So this was designed by.
That's the alternate face.
Yeah.
So if you guys don't know, this is what it's supposed to be modeled after a fish that they call the blobfish. That usually does not look like this underwater. The reason why, like his nose and like his whole face just puffs up, is because of the pressure change, bringing him up from below to the top.
Oh, really?
And it looks like that, and they just called it the blobfish. But I like I like the one with the tongue sticking out, just because of the way that it's designed, so it doesn't require support. It's at a 45-degree angle, so I thought that was cool.
It looks like some sort of cartoon from like Bob's Burger, doesn't it?
It does. The facial
like
features, the way that they design it, right?
Yeah. Kind of like it's coughing.
So,
like,
most weirdest Valentine's gift that you can get.
Yeah. Well, Adafruit likes to keep it weird. I think PT would be. So this is designed by Big Over Easy on Colt 2D. It is a free download. You can download it for free. 2 different versions. It prints like that, print in place with the 7. Count them, 7 legs. There's another version here where it has like 2 legs.
The legs
and
are
this
hilarious.
GIF is hilarious. It's like kind of doing this sort of dance. And I suppose you could paint it.
Yeah.
Reminds me of Crumb from Aria Monsters. Remember Crumb?
Oh yeah, yeah.
He would hold his eyeballs though, but the peach color and the blobby nature reminds me of Crumb.
Right.
Anyway, free design, check it out. Support the designer on Patreon if you like these models.
Yeah, so another cool design part about it is the spacing between the little rings here that makes it flexible. It has a nice spacing, so it should not fuse in even the most uncalibrated printer.
Yeah.
So that should work across all printers.
What did Declan think of it when you showed him? What did he say? What was his reaction?
I posted the video of him reacting to it. They see weird stuff all the time, so definitely nothing that affected them.
That's funny. It wasn't scared
Right.
like, oh no,
No.
I don't like it. Cool. Good filament choice. You know, pink.
Yes, the legs version is killing me. It's a squid.
Yeah. Sorry. This one.
I know I should have did that one.
It's funny. Yeah. 7 tentacles. Yep. Septopus. Yep.
Mm-hmm.
All right. Very strange. Very weird. We like it.
Duopus. The two-legged one.
Duopus. Yeah.
Mm-hmm.
All right. Let's so that's the time lapse of the week. Very strange. Free to download. Try it out. Next up, we're gonna do community makes next. So let's take a look at some community makes. First up, we have a dodecahedron posted up by Willie on printables. This is just a simple dodecahedron design that you can print with no supports. Lots of folks kind of print it out just because of kind of when you have a first printer, you want to do like a cube calibration test. You could print this out as a test to see how good your printer is, or test different filaments out. Anyway, it's kind of a neat shape. It's a dodecahedron if you're a fan.
Mm-hmm.
So you can print that out. Shout out to Willie for posting his make.
Nice.
All right. After that, we have a remix of the heat set press insert rig. So Thingiverse user Gene Z22 posted up their thing. They have a nice description here. They were not happy with the counterweight mechanics, so they changed it to be an ID card system-like solution. Okay, constructed the holder and redesigned the original tri-bearing plate. And they use this ID holder that they linked to Amazon, and it works fine. Printed on a Creality Ender S3 S1 Pro. Very nice. I think there's more photos of it, yeah. Oh, I see. So it kind of has a retractable ID badge mechanism. You know what I'm saying? Mm-hmm. Yeah, that's kind of cool. I haven't seen anyone do that before, so that's neat.
Yeah, I've been wanting to get one for the printer so it moves the wire out of the way. You know how it kind of
there you go.
To the bed.
That's a good idea. Yeah, it's good to reuse these kind of mechanisms. So that's a good idea. I haven't thought of that. Yeah, that's cool. Huh. Good job. All right. After that, we have another heat set insert. This is a custom mounting clamp for the soldering iron. It has like a built-in OLED display. So this was posted up by Random Prints on Printables. They said, whilst I'm waiting for the hardware for me to build the Adafruit heat set press insert rig, I thought I would print all the parts I needed when I came across this brilliant design. It's the pin style clamp by Kemal. Only thing I wanted to do was see the screen and remove the clamp pressure that would be on the screen. So this remix is born. Unfortunately, I haven't built my press yet, so the photos are a bit lackluster, but I will update it when I build it. Very cool. Yeah, love seeing different types of soldering irons used in this design. So it's nice to see some of the more modern soldering irons. They have like LED, OLED displays. That's pretty cool. Looks like it's powered by USB-C. It's kind of neat. All right. After that, we have a make of. This was a make posted on Colts 3D by Jono Grant. Jono Grant made the Star Trek communicator build from a couple years back now. It's all nice and painted. Excuse me. No need to print out the ST button holder. I did not need it. Tricky to get the top and bottom together, but eventually snap fit into place with some patience and no glue needed. Hand painted the silver trim on the outside. Trick to get the outside mesh cover to move up and down while still being affixed to the holder are 2 nails, 1 on each side. There are small holes that you can place the nails into, hold the top cover. They painted the nails black.
Oh, I used 175 filament. Yeah.
Yeah, well, they wanted nails. That works too. Whatever works, you know. Yeah, this design is what, from like 2015 or something?
It's pretty old.
Yeah.
It's ready to come back to life as soon as we get the new cellular
Yeah, this actually
chips.
made phone calls. Right.
This is a real phone, yeah. There's a real
it was a real
SIM card inside there.
Right. Unfortunately, 3G is no longer a thing, and it worked with 3G. You remember buying a phone number? It had like a phone number, and there was a service that probably doesn't exist anymore.
Yeah, no, we sold the SIM cards with the cell phone service on that.
Oh, yeah. So the phone, maybe this will get a remix.
Coming back. She's been checking out the new modules, so one of these days we will revisit and remake a actual phone calling Star Trek communicator.
Yeah.
Funny, the numbers programmed to Phil's phone.
Did you design this in like Maya or something, or 123D?
Oh, this
design?
is Fusion. No, this is Fusion.
Oh, yeah. Wow. Cool. I thought
because you built the CNC paths for because we used the metal.
Oh yeah,
great thing. Yeah, you made the paths for the CNC for the Bantam poles.
Mm-hmm. Yeah, that's fun.
That's not the name anymore.
No, it is.
No, it is Bantam.
Yeah, it used to be Other Mill.
Other Mill. That's what I was thinking. Oh, that's nice.
Yeah, back when it was called Other Mill.
No, okay. I like that Bantam is burnt into my head instead of Other.
Yeah. In the last project, we saved the best for last. This squid.jpg, he posted up their custom firmware for the ANO fidget NeoPixel project. Super awesome write-up on 80freeplayground.com. The code is available on GitHub, which you can download. You can either clone it or download the zip with all the library dependencies. Super awesome. This reads a lot like a Native Root Learn guide. All the code is broken down. All the different modes are explained here. There's a spin the bottle mode, a rainbow particle mode, power meter simulator mode, and the Simon Says style memory sequence game. So I went ahead and tried it out, and I have it loaded on my fidget device. Let me see if I can switch my camera and just kind of give a little demo of it. So here's the our version uses the 24 NeoPixel ring. Squid.jpg's version has a 16 NeoPixel ring, but it's adaptable. So I just turned it on. It starts off with one white LED, and this is the particle mode. So as you rotate, it accelerates if you spin it faster, and then you can use the directional buttons. You want to full screen me? You can use the directional buttons to change the color of the background LEDs and the foreground LEDs. So like the particle that's kind of moving. So here you can see this really nice color combo, and it's super responsive. So you can change the colors. You can rotate it backwards and get this really nice inertia kind of effect going on. And if you hold the select button down, it kind of reverses a little bit. If you press and hold down for a second, you'll switch to modes. So this is the rainbow particle mode. Rotate the rainbow. As you rotate it, press to get these kind of cool effects here. And then the directional buttons have these kind of directional kind of flashes going left and right. Super cool. The code is really nice and versatile, where you can kind of change up the pin assignments, and it kind of scales depending on how many pixels you have in your setup. You also make so you can use either the STEMMA QT version of the ANO or the breakout version of the ANO. So it's really easy to kind of switch between those two in the code. Let's check out the next version. This is the battery simulator mode. Kind of has this nice, yeah, it's super cool. And on top of that, you can change the colors of either end of this by pressing the directional buttons. So that's really cool. And then let's see, the last mode is Simon Says, the memory style game. So you have this kind of pre-game to start it. You'll want to press and hold on the green, and then it starts the game. It dims it, and then there's the memory. You have to match the pattern using the directional buttons. So that. Oh, I got it wrong. Yeah, very, very cool. Really, really cool. This really extends the the memory matching, or the fidgeting.
Wow.
So very fun. Really good use of the NeoPixels and the Rotary encoder. So big shout out to squid.jpg. Definitely check out their post on Adafruit Playground. You get a really nice breakdown of what he went through to make it do all the things. Excellent use. We love seeing it when folks like take our projects or any other project in this Learn system and just like really make it
expand
that much. Yeah, that much better. So fun. Definitely update it, Pedro, for the kids. They're gonna love playing with it.
I gotta find it first.
Yeah, you gotta find it. They have it somewhere.
I keep taking all the stuff.
Very cool. So shout out.
Something I wanted to say. Squid says he added a late addition. It is motion blur. Check that out. For the rainbow particle mode, there is now motion blur.
Wow. Very cool. Yeah, I'll have to. Yeah, I grabbed it yesterday evening. So if you just updated your GitHub, I'll have to try it out. Very cool. And definitely, folks, if you want a place to publish your projects, documentation, photos, definitely check out Adafruit Playground. It's kind of like a carbon copy of the Adafruit Learn system. So you have like a nice kind of editor for creating cool blog posts, and you'll get featured on the blog and all that stuff. So
cool way some of the functionality of the Learn, like having the project bundle and things like that, and the code embeds.
Yeah. I'm just having fun. That's the end of the show. We're just playing with the squid.jpg firmware. Cool.
Oh, he says you might already have the latest build.
Yeah,
if you got it yesterday.
It's really, really cool how all the different, like, it's slowly pulsing, fading. That's a good way to kind of let the user know that you haven't started looking at. Yeah, the idleness of it is really cool. So fun.
Yeah,
go build one.
Kids are gonna have a blast.
Yeah, super fun. All right, that is going to do it for the show. Don't forget, if you want to pick up anything from the Adafruit shop, you can use our 10% off discount code CLOCKTIME. And what else? Tonight. Yeah, you got another question?
Yeah, somebody's asking if we've done any work with the bracelets that they have at concerts. I think John was gonna maybe poke at the LED bracelets that they got at the Taylor Swift concert.
Right. Yeah, I think he had a discussion about it. I'm not sure if he took it apart or he was talking about the protocol.
Looking at it. Yeah.
Yeah. So check out JP's workshop on Thursdays and look back at his playlist and see if there's some info that might interest you there. But tonight we have back-to-back shows, starting off with Show and Tell, starting at 7:30 p.m. Eastern Time, hosted by Liz Clark. You can come by on the Discord server, get an invite link to the StreamYard so you can join in. Love to see your stuff. And then at 8 p.m. Eastern Time is Ask an Engineer with Mr. and Mrs. Lady Ada. We'll get some open source hardware news, some new products, Ion MPI, and more. Tomorrow is JP's product pick of the week. Wait, no, it's not. It's JP's workshop. Where's my... There it is. JP's workshop. It starts at 4 p.m. Eastern or 2 p.m. Pacific, I think. Am I right? Am I wrong? I don't know. Check the Adafruit Discord show times. You can always use the showtime code to get all the different listings. Fridays is a deep dive with Scott. Scott's back. I need to update this this graphic. But sometimes it's Tim, Foamy Guy, who comes on Fridays at 2 p.m. Pacific or 5 p.m. Eastern to do a deep dive live stream. Sundays are From the Desk of Lady Ada live streams. Mondays are CircuitPython weekly community meetings. Tuesday is JP's product pick of the week. And then we're wrapping back around to Wednesday mornings with our show, 3D Hangouts. It's not Thursday. It's supposed to be a Wednesday. Jeez. My old out of date, my graphics are out of date now. All right. Thank you, everybody, so much for joining us. This has been an Adafruit production. We'll see you tonight on Show and Tell. But until next week, remember to
make a great day.
We need to work on that. We need to synchronize ourselves. Bye, everybody.